All right. I thought that I would start the live stream on time. Joe Tegtmeyer will be joining us momentarily, but wanted to start things so that we can have people join. And I feel very rusty doing this. I haven't done a live stream in a while. And I just got back from a 3-week international trip. So finally feeling, resettled here in Austin. I'm engaged, and there's just been a lot happening. However, we still haven't had a Starship launch since March 6th. So hard to believe we're coming up on 2 months, or maybe not that hard to believe considering that they, lost the ships on both Flight 7 and Flight 8. So what is going on with Flight 9? When do we expect it to be? And, hopefully they're able to solve this problem that led to the loss of the ships on those last two flights. So, while we're waiting to get started, I just wanted to say hello to everyone. Let me know where you're checking in from. If you have any questions about my trip, I'm happy to answer them. I'm working on a video, another Disney Tokyo review. And I'm also working, this is not for Ellie in space, of course. People get mad if I don't talk about space on my channel. And I'm also working on a video about my tour of the DMZ, the demilitarized zone in between, of course, North Korea. Oh, what is going on there? And let's see here. And South Korea. So let's see. We have Aaron checking in from Victoria, BC. We have, I'm sure I'm butchering this, Nick from Harrogate in the UK. We have Bimmer Geezer, congrats. Thank you so much. Just a little recap. I will say I was completely caught off guard. My fiance and I picked the ring together, so I got to pick it. However, I didn't know if he had bought it yet. And so when he pulled the ring out of his pocket at almost midnight in Seoul, South Korea, we were overlooking this beautiful viewpoint on sort of a midnight hike, and it just totally caught me off guard. And I was in total disbelief and asked him, "Is he sure? And did he think about it?" Are you sure? Have you given this thought? Which is maybe some dumb, silly questions. But yeah, so that's very exciting. Now I'm trying to plan a wedding. We have, do we have a date for our wedding yet? Not yet. However, we are trying to do it in just a few months because I would like to have a baby. So, so there's just some personal updates, but let's see. We have Gilberto checking in from Mexico. We have Tony nearby in San Antonio, Texas. We have Brett checking in from Houston. So a lot of Texans in the chat. We have Marcus from Stockholm, Sweden. That is awesome. I would love to go to Sweden. There are so many places that I still want to go. But I'm very glad with how much international travel I've been able to do recently. I loved South Korea much more than I was expecting to. And of course, love Japan. Taiwan was also very cool. And so, yeah, we have Joe from Maryland. And speaking of Joe,
I'm back.
Joe Tegtmeyer.
Yeah, I'm having some house repair work, and there was a circuit breaker issue. So hopefully it'll be okay now.
Oh my gosh. Well, hopefully, if you have to step out again, that's fine. I was just telling them about, being engaged, and
Congratulations, by the way.
thank you. Yeah. So that's very exciting. And just a lot of things going on. I loved the trip. You've been traveling a lot lately too, although not internationally, but still very exciting. You haven't seen KSC in many years, so
yeah, that was great. I enjoyed my trip out there a lot.
yeah. And you're able to get some video and some more information. So I think that we'll start with what's happening right now. I think most importantly what's happening with Flight 9. A lot of people want to make plans to see that, and so let's start with this video here, little clip from Lab Padre. This was last night. So SpaceX was wanting to do a static fire 2 nights ago. Unfortunately, they had to abort that for some reason. I'm not sure if we know.
Mm.
Probably more issues that they had to figure out. But this is a good sign of progress. However, as you were noting, this was only one engine, and so next up they have to do all 6.
Right. That's what I'm hearing, is that they're kind of methodically going through the process of getting ship 35 ready to go. And as your viewers know quite well, it's based on 33 and 34, and they didn't do so hot. So, you know,
Well,
they're
they were
really
hot. They were hot, a little
Yes,
too hot.
in the wrong way.
Yeah. Yeah, and so so when do you think that they'll be doing, the full static fire? And let's just talk about like what's next, in order to get to Flight 9 and when we think that might be.
Okay, well, that's a good question. Obviously, they're in the testing campaign now for 35, which is great. Over the last 2 months, they've spent a lot of time working on Ship 35 to get it ready for this test regime. They've also done cryogenic tests on 36, so they're getting 36 ready to go. They've done some of the rehab work on booster 14, and they did another static fire with booster 14. So the very first booster to do a second static fire, or a static fire after it's flown. And it looks like it's got its hot staging ring on as it's in Mega Bay 1. So, and then they did some testing with booster 16 as recently as well. So they have 14 ready to go. They have 16 partially through its testing regime. They've got 36 partially tested as well. 37 and 38 are in various stages of assembly. And then now 35, they're ready to do the testing. And, they're going to try to validate whatever fixes and repairs that done to 35 along the last couple of months to get ready. And it seems to me is that they're going very methodically this time. We're going to start with a single engine. Well, they did some cryo, then they do a single engine, and then we're going to see another one. Assuming all of that goes well, it could be just a few weeks after that when they're ready to try to launch it. So it's, coming up soonish.
Which I do want to emphasize, I'm sure most of you know, but if you're not familiar with like the numbers, of course, booster 14 was the first caught booster. And so, right?
That was the second one.
Oh, second one.
Actually, it was the second one, and it was the third. 12 was the first caught. The 13 went the offshore divert, and that was where you were really bummed about that.
Oh,
and then
okay.
Came back to the second one.
So this is the one from January.
Yes.
Right. Why do you think that they're not using the one from October on that perfect flight that we both missed?
Well, that would be booster 12, and I think maybe one. Not that SpaceX is very nostalgic, but maybe they want to do something with it, display it or whatever. But more likely is it's got older design elements on it.
Yeah,
so
actually.
I think maybe they wanted to go with something a little bit more current, and that would be 14, 15, 16, where we're at right now. Another question would be is why are they not reflying 15 versus 14 since both of them were caught? My guess is that just 14, they've had more time to go through the systems and get ready for it. Right. So,
but I guess I wanted to pause on that, although I was confusing which one it was. Yeah. I wanted to pause on that because that's a huge milestone.
It is.
Not only, retest on the ground here the booster, but to refly it. That's huge in our, quest to be fully reusable. So that's very exciting.
It is, and it's going to give them a lot of experience with what is it like to catch a booster, refurbish it, get ready to go. But I would also say it's I don't know if risk is the right word, but they're kind of laying it a little bit on the line by doing a reuse of a booster on an extremely important flight to get the ship through its flight regime and at least through the reentry part of the mission. So, they're kind of rolling the dice a little bit, with that.
I mean, they just have so many, goals and things to check off their list to get it right. So I don't blame them. That's kind of just the way that they've moved ever since the early days with SpaceX, and it's actually worked out very well for them. So obviously sometimes the public sort of takes any perceived failures and misconstrues them, but I really hope that they have a successful Flight 9. They really do need it. And we said that on Flight 8, and they really, really need it now. So
Yeah, well, especially if we look a little bit forward in time of what SpaceX wants to do. And I'm still going to call it an extreme stretch goal, but they really want to try to launch some Starships towards Mars at the end of next year for that transfer window.
yeah.
And, what happened with Ship 33 and 34 has been a setback in time, at least.
Right.
So they really need a win so they can build on that.
Yeah, and Ross brings up a good point. I've been hearing this too. I've heard rumors that Booster 14 won't be caught on its second flight. I've heard that as well. Have you heard that?
Yeah, what I've actually heard is that there's a lot of give and take and discussion going on within SpaceX, and it has been for some time, about what to do with Flight 9. Do they want to add different tests or not? Originally, there was some discussion about trying to use Booster 14 in an expendable mode so that the ship had a better chance of getting to orbit. And the way they would do that is use more of the performance of the booster and have less requirement for performance of the ship, which would theoretically make it less stressful on the ship and hopefully get it into that near orbit so they can do the rest of the parameters what they wanted to do. Then that was changed a little bit to maybe we'll use Booster 14 and test engine out scenarios to see what would happen if only 2 of the 3 center engines were lit. Could they still maneuver and be caught? Or maybe they would do some other various changes on the flight profile or the controllability, maybe on its return trajectory. So I've heard a little bit about that too. And then all that would be an offshore divert kind of landing because they're testing a lot of off nominal things. But they've also been doing an extensive amount of testing with the chopsticks on the launch tower very recently, and they've been going through all of the various motions of seeing what is it like to catch it on different parameters. And some of that's been replicated on the second tower. So I don't know if they're testing and getting data from Tower 1 and the chopsticks and then seeing what happens on Tower 2, because those chopsticks are a little bit different, or if they really do want to catch Booster 14. So I don't think there's anything official yet, and they could come back for a catch as well.
I wonder, though, I think that it would be helpful for us to know, because I would bet that, less people would want to go.
Yeah.
I mean, the launch is still great, but, it's not exactly easy to get down there. And so if it's really hard to plan for, you need to see the catch, right? And so I hope that we know in enough time so that, people can plan accordingly. I mean, you and I are lucky to be, within a day's drive or, a very relatively easy drive. Right. And so I hope that they make that publicly known so that people don't get their hopes up. Because, I mean, again, we are kind of spoiled. It's still amazing to see Starship launch, but seeing a catch is otherworldly.
Yeah, well, the catch is cool. It's the falling out of the sky at unbelievable speeds, which is really amazing.
It's nuts. I mean, it's like it doesn't even feel like it's real what you're looking at, and it's real. I mean, I think it's real. You know what I mean? But it still feels like, wow, this looks like CGI.
Well,
and it
not
also
only that, but this is way too fast. There's no way they're going to be able to stop.
I was going to say the same thing. All the times that we've seen it, it's looked too fast, and then somehow it gets it together. But it's just so cool to see it. It is, it's great. It's great. So, it will be a little bit of a bummer if they don't do it on Flight 9, but let us know.
Yeah. Well, hopefully once the Ship 35 static fire is done, they got the data and they're confident they're going to send out, at least give us basic idea of what to expect and a timeline. So hopefully that'll be coming maybe this week. We'll see.
And Ross wants to know, what's your preference for watching Flight 9? I'll ask you the same thing, Joe, because now we have been, fortunate to see it from a second viewpoint. So we've seen it from, a residence in that gated Port Isabel community. And so it's like a different angle. I think it's roughly the same distance, but just a different angle. And then, of course, the roof of Margaritaville.
Yeah. I think I don't know. I kind of like Port Isabel just because we were lower. We were right
Yeah.
on the ground, and you could just look straight across and see the tower, and the tower was basically on the same elevation as we were. So that was kind of
Yeah.
cool.
It did feel a lot closer, I think, for that reason, even though it wasn't, like in the exclusion zone, it almost felt like you were.
Right, right. And of course, when we saw it last time, the wind was blowing right at us. So all of the sound, all of the dust, everything was coming right at us.
Yeah, no, that was next time I will not run inside of the house. I
Well,
will
now
not.
you know what's going on with your leg, or at least you have a pretty good idea.
I mean, from an orthopedic surgeon's perspective, that was a really cool interview. By the way, I just interviewed him yesterday about why he really thinks that there needs to be at least one, if not more, orthopedic surgeons on the first flight to Mars. So I'll be editing that video, but I think he makes some good points. And thank you for the first super chat of the live stream. Very generous from Bimmer Geezer. Joe, long time no see. Ellie, always your best guest. I agree. I
Well,
can't
thank you.
believe he does this unpaid. Um, it is pretty crazy. So let's get back into the little video. So again, this is from last night.
Mhm.
And so, it's up in the air. We could be seeing Flight 9 very soon. We know that SpaceX wants to go as soon as humanly possible. But I guess we'll have to see.
Right. And we'll talk a little bit more about some of the details, but you know, they are to some degree limited how much they can test on the ground too, because there's certain parts of the flight regime that you have to do in the air or on the go. So, I think that they're trying these kinds of tests now to do everything that they possibly can to get ready, but there's still going to be a degree of uncertainty until they get it in the air.
Right. And so now we're into your slide section. Is that good?
Yeah. I'll just ask me questions. I'll just sort of jump around on it. But as you know, I was just recently in Florida, and as I mentioned earlier, a lot of people have been drawing comparisons, at least people who know about space and rockets, about how the fuel tanks are oriented and how the pipes go through the tanks and what they did on Saturn V versus what's going on with Starship. And they're saying, well, if Saturn V could solve it, why can't Starship, or what's the difference? So when I went there, I specifically went to the Saturn V museum to get these particular shots so that we could have this discussion. And what you see here is actually cool. Is up at the top is an actual Saturn V. I think that one was going to be used for maybe Apollo 19 or 18 if that had happened, but it didn't. So that's a real, at that time, flight-worthy Saturn V, the full thing, all on display in this museum. And then below it is a mock-up of that same Saturn V, and they show how the entire thing is built. And if we go to the next slide, we can get an idea of that kind of that fuel tank orientation of what we were talking about. And what this shows is on the left-hand side of the screen is kind of a schematic with the Saturn V in a vertical position. And you can see in first stage only, you can see the LOX tank on the top, and you can see the RP-1, the rocket fuel tank on the bottom. And to get the oxygen, the LOX, from that tank to the engines, they had to have those pipes that went directly through the RP-1 fuel tank. And on the right shows you what that looks like. I colored one of those lines in purple so it's easier to see. But this is something that Starship is incorporating now. And not only are they incorporating it, but they made some recent changes with the version 2 of the Starship that looks a lot like this. So, when we talk about ship 33 and 34 and the resonance issue and what happened, this is what we're talking about. These fuel lines that are going through these tanks and how they connect in and then bring that fuel, or in this case, oxidizer in the Starship, it's methane, to the engines. So we can go to the next slide.
I was going to say, I think later in the slides, we talk about the previous design versus the new design.
Right. And I just show you this real quick. You can see this. And one of the things that I want to show that may be a part of what happened with 33 and 34 and might be what they're trying to address with 35 and testing is you can see those kind of supports that I have highlighted in yellow. those were added on the Saturn V to support those lines within the middle of that tank. And that helps in a bunch of ways. It helps with how the frequency of the pipes responds. It helps with kind of the bending moment of the pipes, but it also effectively breaks the pipes into two smaller sections. And that may be a strategy that Starship is going to try to incorporate as they're doing some of these fixes. So we can go to the next slide.
Yeah, sorry, I had to ban an annoying, weird user.
Okay.
Okay, here's the next slide.
Okay, so this is getting to the comparison now of Starship and Saturn V. The same diagram on the left with the Saturn V, and now with the Starship, you can tell that between the Block 1, which was all of the Starships that we saw fly and re-enter successfully with those really amazing Starlink videos of them going through the atmosphere. And then on the one on the right is the upgraded or changed version of the Starship. And you can see a number of changes. One of them is that the fuel tanks and the oxygen tanks are larger and a slightly different configuration. But if you look closely, you can see that they now have 4 of those pipes that go through the LOX tank. They have the central pipe, which is similar to what they had before, but instead of some pipes on the bottom where they have these manifolds and it branches out from that central pipe to the outer engines, instead they put these 3 other pipes that go from the methane tank all the way down directly to the engines. And this is what we suspect is related to the issue.
But why did they do this?
That's a good question. And this is actually kind of thinking ahead to the future. Future versions of the Starship are going to have 9 engines. They're going to have 3 center gimbaling sea level engines that will be so that you can direct and steer the rocket. And then they're going to have 6 vacuum optimized Raptors around the periphery. And the original design just was not suitable for having that many engines. So they changed the design partly so that they have more fuel, but also so they can feed those engines more directly. And so as a consequence of that future design, they added this design element into the Starship. And ever since that has happened, we've seen what's been going on. So they're kind of struggling with this design right now.
Yeah.
But we can go to the next slide, and we'll see what this one is. And this is a render. This is from a Chameleon Circuit, also the Ring Watchers. So just want to shout them out. They do excellent work.
Yeah.
This shows you what it looks like if you were at the bottom of the oxygen tank looking up to the common dome, which is just at the top. That's where the methane would be. And then you can see those 4 pipes that come down from that methane tank through the oxygen tank, and then they connect at the bottom through connectors, and then they go to each of the engines. So one more time, if you compare this with what they're doing with the Starship to the Saturn V, you can see that there are some similarities in that design.
Okay, next slide.
Okay. So this is a little bit busy, and I'm not going to go through every single thing, but if your viewers have questions, or if you have questions, that would be great. But I just want to go over what are some of the differences in the Saturn V versus the Starship, and why this may be contributing to some of the issues. First of all, the Saturn V used 5 of these really large 17-inch, so like 1.5 foot diameter pipes for their F1 engines, whereas the Starships, they're using 4. I don't know what the dimensions are of them, but they are going 1 large pipe for 3 center sea level engines, and then 4 smaller pipes that go out to the Raptor engines. So how they're doing the plumbing is a little bit different. In addition to that, the Saturn V did not use vacuum jacketed pipes, and the main reason why is even though cryogenic fluids are going through the pipes and through the rocket propellant tank, which is basically at room temperature, it wasn't that important because the Saturn V didn't last that long. It was just a few minutes and then they jettisoned it. So it didn't need to be in operation for extended period of time. Maybe some of your viewers will know, but one of the big upgrades for Starship V2 was the addition of these vacuum jacketed lines, and that's so that they can do longer missions. But that also introduced some problems that may be related to the harmonic resonance issue that we are seeing. So that's a big difference between the Saturn V and the Starship. Another one, and we'll get lightly into some math a little bit later, but the length of the pipe is a big issue. So I wanted to compare the size of the Saturn V rocket propellant tank, that fuel tank, versus the LOX tank to see, did it make the pipes a lot longer in the Starship? And it does by a couple of feet, not dramatically so, but the pipes are actually longer in the Starship than they were in the Saturn V. And that's going to be an issue when we get to how harmonic frequencies operate. And it will give us some idea of what maybe SpaceX is doing to try to fix that.
Right.
All right. Good question there. Talking about durability of the Starship. Durability is a part of it, but it's more really important to keep the cryogenics cryo. So we need to keep them liquid for long periods of time with the Starship, unlike the Saturn V. And by having these vacuum jacketed pipes, it's one of the strategies that SpaceX is trying to do with Starship to allow the cryogenics to stay liquid for as long as possible.
So, but my understanding, or maybe I don't know if I understand it fully, the root cause of both of the losses was not necessarily those vacuum jacketed feed lines, right? Or was it?
It was most likely related to this. Now, there is a small degree of speculation here because SpaceX wasn't 100% clear. And it's also, I'll be honest, it's not 100% clear that Starship 33 and 34 were exactly the same problem. But from what I've been hearing is it was not only related, but whatever fixes they did on 33 actually made it worse on 34. So that's why they have to go through this process of testing.
Right.
But the getting these pipes vibrating is kind of like if you take like a metal wire and you bend it back and forth a lot, what happens eventually? It breaks. So when you get into these harmonic frequencies, and if they get it to the right frequency under various conditions, it can actually break the connections or break the pipe itself. And then you either have mixing methane and oxygen in the oxygen tank, which is never good, or the connections between the methane and the pipes going into the engines themselves could break. So that's why this is such a big issue. And then just a couple other things here. Vacuum jacketed pipes, they add structural complexity, which is always something that you want to try to avoid if you're SpaceX. And it's designed to minimize that heat transfer, but it can also cause structural issues with the pipe. And again, that's something Saturn V did not have to deal with because they did not have vacuum jacketed pipes. Another thing, and it's sort of a contributing factor. I mean, with everything with rockets, it's kind of like if you fix one thing, it can make three other things go bad. So it's a balance between what do you fix and how does it impact other things that may have been working fine, and now what you just fixed is going to make other things worse. Cryogenic fluid, as they flow, they have very low density. They have the viscosity is low, and obviously the temperature is low. So that affects the fluid flow, and it also affects the structure, the pipes themselves. And of course, things with resonance frequencies, it can be contributing by like pumps as they're pumping the fluid through. If the pumps have oscillations, then those oscillations go through the fluid and they get into the pipes and the rest of the structure. So all of these kinds of things can be introduced into this pipe-like system, and that's pretty much, I think, what SpaceX is trying to deal with right now. So hopefully that makes sense. And there was that other question that popped up. I don't know if I answered that one or not.
Oh, it was just a comment. And then, the leg tells us what the pipes experience. I'm not thinking about that, but it's like kind of.
Yeah, exactly. Exactly.
Let's see. Why not mount the pipes to the frame instead of free floating?
That's actually a good thing, a good idea. And that's kind of like what Saturn V did. And that's something we'll talk about here in a moment. And ironically, even though putting brackets on the pipes may help as far as the the length of the pipe and changing the frequencies just based on that alone, it can actually contribute to other frequency issues. And I'll show you that in a moment. And again, that's that rocket thing where you fix one thing and another thing kind of goes out of tolerance. So you fix that and something else goes out of tolerance. And I know that you've talked to Tom Mueller out at Impulse and what he was doing with the early Merlins. And I'm sure he could talk to you about how that just drives you crazy when you're working on rockets.
Yeah. Oh my gosh, for sure.
Yeah. But I know this is wordy, but just a couple other things. Something called boundary conditions, and this kind of goes to the previous question. It's how are the pipes actually connected to the bulkheads and where the pipes come out to the engines, and how that is done, whether they're flexible, whether they're hard, whether they have bends, whether they allow movement or not, or how much movement, that all really is a big contributing factor to resonance frequencies. And that's why when we were talking about the static fire, I mentioned that there are some things that they can test on the ground, and there's some things they need to be in the air. And so as they're doing the testing and the static fires, they need to get to a certain level of confidence that they're ready to try to fly, but there's still an amount of unknown that they just don't know until they get it in the air. And this would be one of them. We talked a little bit about the fluid, how pressure waves go through the cryogenics, and it can affect the pipes, especially if they're at very high velocities and it's a rocket. So you can imagine the amount of flow through those pipes can be quite high, and that can contribute to some of these issues. And of course, the temperatures themselves, it actually changes the material properties of in this case, the pipes, the stainless steel, and it can make them more stiff. It could make them more brittle. It can increase the natural frequencies as well, which might be related to as the LOX tank gets lower in the amount of cryogenics around the pipes, then it may be changing the natural frequencies as that fluid level gets lower and lower. And what we've seen with ship 33 and 34 is that the problems started up around the 7.5 minute point,
right,
which means that the LOX tank was maybe a half to almost a quarter full. I think they had less than a minute until they had MECO. So the LOX tank was getting much, much lower. So the effect of the cryogenics, the effect of it kind of dampening out some of the vibrations started to maybe persist at that point in time in the flight. And that's something that's very difficult to replicate on the ground during static fires, especially since we don't want the ship to lift off. So you want to have a lot of weight in it. But if you reduce the weight so you can get to the same conditions, then it's a lot more stress on the hold down clamps.
Right.
So let's see a few other things. I mean, I'm not going to go through every single one of them, but what I'm trying to at least give a window into what they're dealing with is just the complexity that is involved when you change a design, you add a new element, and then now all of these other aspects of that design come in, and you've got to work your way through each one of them. So go ahead.
Tesla Tina wants to know, if it hasn't been discussed here, do you still think Starship requires a full and detailed design review and perhaps significant hardware changes that are not easily done in the existing ships?
Great question, Raphael. Appreciate that. We got a chance to spend a lot of time out at Florida together too, which is really great. We saw a couple of launches too, which is nice. But I think that, we recently saw Elon talk about V3 and how they're wrapping up the design for that. And it kind of caught some people off guard because, hey, we're in V2 right now and you're already talking about V3.
Right.
I think that is at least a little bit of a window into the thinking process that they want to try to get whatever data they can out of these ships, since they have 35, 6, 7, 8. And I think 39 may still be a V2. I'm not sure if it's crossed over to V3 or not. And they're already starting to work on 40 and probably some more. So they have a degree of hardware that, they know that there's probably some design challenges with this current version, and that they're incorporating a bunch of changes into the V3. But at the same time, there's still a lot of data that they want to get, specifically about heat shields. There's a lot of testing that they really want to get out of that before I think they commit to what design they want to do with heat shields. So these ships still have have a lot of, value with getting them in that near orbit, getting them through reentry, getting all that data. And unfortunately, they missed out on that on 33 and 34.
Right.
But I'll also say that what's telling is if you look at 36, 7, 8, and 9, they have very few tiles on them. And I think it's because they really need that data. So, and D2 also introduced some aerodynamic changes with those forward fins by moving them up, shrinking them, moving them out of the wind flow, redesigning the interface between the body and the flaps. They still need to be able to test that to verify the data that its controllability is what they need. And it also helps address that heat flux problem that we saw with the earlier versions, burning through the flap to body interfaces. So there's a lot that they could still get from these ships, but I think they pretty much realized that this design that they have right now is probably, they might be able to put a Band-Aid on it, but I don't think that this is the design that they're going to go with.
For sure. Okay, here's the math section.
Yeah, and again, I'm not trying to turn you into a rocket engineer, but I want.
Good luck.
I know. But the way that you look at this is one of many equations that is used for harmonic frequency study, and there's a bunch more. I've simplified it, believe it or not, a lot. But
no,
but hey, it's rocket science. What can I say?
What am I looking at?
This is the kind of the equation that has to do with natural frequency of a pipe and transverse or bending mode. There's a lot of different modes, but I just chose this one as an example of what they could be looking at. And so it's not just, hey, we're going to weld this pipe together, we're going to stick it in and hope it doesn't vibrate. There's a lot that goes into these designs. And the way you look at equations like this is whatever is on the numerator or on the top is a direct correlation. So if you make something on the numerator bigger, it's going to make the answer bigger. And if you put it on the denominator, if you make those bigger, then it's going to make it smaller. So if you look at this equation, you can see that there's some things on the numerator, that's the top part of the equation, and there's some stuff on the bottom. Some of the items are squared, which means that their impact is significantly more than if it was just by itself. And then you can see some other factors. And the last question is what of these things can you actually adjust? And so this is kind of what SpaceX is looking at, stuff like this. And they're saying, okay, what do we have control over with the design of the ship or with the fixes that we can do right now? And what is outside of our control because it's either something we can't fix right away or if it's just a material property. So, if you look at this, one of them is something called this eigenvalue, and it actually has to do with where the pipe is connected and how it's connected. So we were talking earlier about, well, if they put a brace in the middle of the pipe, kind of like what Saturn V does, wouldn't that just solve the problem? And the answer is it's not really solving it so much as it's changing the harmonic frequency. And you can see it's on the numerator, so it's squared. So whatever change, if you make it a little bit bigger, then the impact on the frequency gets really big. So it makes the frequency bigger, which means it's faster. So it's, if you think about a really low frequency, it's low. And if you think about a high frequency, it's really, really high. So they're changing how it responds. So by where they put the connections and how they affect the pipe where it's fixed, will affect the frequency. Another one is the length of the pipe. And that's why I was talking about with the Saturn V comparing the lengths. If you make the length longer, then you can actually reduce the frequency. Or if you need the frequency higher, you need to reduce the length. And the size of the tank is kind of fixed, so they really can't fix the length that way. But if they put braces in the middle of it, they can reduce the effective length of the pipe, and then that changes the frequency. And then there's a few other things that have to do with the material itself, the stainless steel. You can maybe change the thickness of the walls, or maybe you could change to a different material. But if they're already committed to what they have, then that can't really change much. And then there's a few other things. But ultimately, what they're faced with fixing is either how the pipe is connected physically, whether it's bellows or flexible couplers, whatever, the length of the pipe, adding in connectors to basically change the length of the pipe, or a combination of those. And they can also, I think they tried this on ship 34, they can change the operating power of the engines, which means it reduces the pump speed, which means it reduces the cryogenic fluid speed, which changes the frequencies as well. And I think that they thought that they could get away with that with 34, and it didn't work. So now they have to do some hardware changes. So anyway, I know that's really deep, but this is what they're trying to do.
Okay, so I just want to have a moment for interactive audience participation.
Sounds good. Sorry.
Tell me if you understand this slide. If you're watching this live stream and this is like a breeze to you and you understand everything that Joe is saying, I will be extremely impressed with you. I am actually curious how many people in my audience, I mean, we don't have my whole audience here watching,
Right.
but you know, how many of you guys understand this math? And maybe you're an engineer, because we have some people saying, yes, easy. I do. I feel like I don't even know how long, Joe, if we were to hit it really hard and you were to try and train me to understand this stuff, I do not know how long it would take me to understand this. This is very, very, okay, everyone apparently.
Well, the most important thing is, if you just look at the equation, you see what's in it, then you can ask yourself, well, what of that can I change? And if I change it, what does it do? So that's kind of what the process is SpaceX is going through, is if they make the pipe shorter, what does that do? Can they make it shorter?
Right.
And then once they make all those fixes and they do some computer testing and some analysis, and they're kind of confident of what they've done, then they take it out to static fire. And then they do a regime like we're seeing right now with static fire, and they're seeing, is it possible that they fixed it, or did it make it worse, like what happened with 34? They can only go so far, and then there's going to be parts of it that they just have to fly it. So they're going through this process right now, and this is why it's hard, and that's why I wanted to at least show a small example. So hopefully that helps.
Gary wants to know, can I use this slide in my physics class?
Sure.
I mean, yes, I feel like I understand, what you're trying to tell me, but as far as looking at that equation,
well, some of this stuff, like the eigenvalue, is something you have to test for. So you actually have to run a test to find out, okay, we just changed something. Now what does it do? And then they know what that particular design is. But then you change something else, and now you have to test it again so you can get the new eigenvalue to find out what it's going to do. So that's why it's almost like a maddening repetitive cycle that you go through as a rocket engineer. And this is why, if you talk to SpaceX people, they just say, oh, this is so hard. This is why.
Well, I guess I was wondering if people watching would be like, oh, well, for me, I'm like, I'm having trouble following this. It's a little bit hard to follow, but apparently y'all understand it. It was very exciting. And
well, I'm trying to keep it as relevant as I can. So when we talk about, well, the harmonic frequency was the problem, whatever. Well, this is what they're talking about.
Yeah. Well, I appreciate how smart you are, Joe, and how willing you are to share this with the audience, because I could not do this.
I'm sure you could.
Okay, well, I will not do this.
Right. This last one is all I wanted to show is some of the things that they could attempt. Like we talked about, pump frequencies, flow rates. They could put software in. They could change that, see how the engines are working, and that's why we were talking about booster 14, maybe using more of its performance so that there's less performance need on the Starship. That would be an attempt to try to reduce the flow rate, because they don't need as much performance from the Starship. So they could try that. They could do some dampening materials and stick that onto the pipes, or do different connections, and then they have to test that. We talked about the bellows. They could change maybe V3 is going to change the design of the actual vacuum jacketed pipes themselves based on this. So that's something they could do, but that would be an extensive design. And they have to make sure that whatever the design is of those pipes is tested, and they know what the frequencies are and how it responds based on the temperatures and with the cryogenics and so forth. And the other thing, it's just turbulent flow, and that just has to do with the flow through the pipe and what they can do to make it as less turbulent, more laminar, more of a smooth flow through it as they possibly can. So, and let's see what is Michael said. Yeah, so and that's what we were talking about. Saturn V only had to last for about 2 minutes, the first stage. So they optimized it as best they can so that it can survive in that period of time. If they had to use the Saturn, if they attempted to reuse the Saturn V again, or if they had to go longer than the 2 minutes or so, maybe they would have had this problem again. So, that's part of engineering too, is you figure out what is the operating environment that you need it to work in, and then you optimize the design for that environment. And Starship's, that environment is so much bigger. It's such a bigger challenge. And I hope that this discussion at least gives us a window into the much different nature of the Starship than it was, say, with the Saturn V.
Right. Okay, let's see what the next slide is here.
This is just the wrap up. This is an actual image. I did color the pipes, but you can see how they are installed.
Wow.
And, they do come at an angle, which suggests there may be at least some degree of support somewhere. I don't think it's just hanging down from the common dome, but this is an actual, I think that was ship 33, and that's what it looked like as it was being assembled. And
so Ross wants to know, out of all of those, possible solutions, what do you think the best harmonic resonance mitigation strategy is?
I don't think there's going to be one particular thing. I think it's going to be multiple. And again, it goes back to that operating environment that the Starship is going to have to be working in, because it's going to be on launch. It's going to be transit time through space. It's going to have to then be able to relight and go through a different atmosphere and then be able to survive all of that, because in all of those regimes, they're going to be using at least some of the main engines to some degree. And then, of course, when it lands, I don't know what that design is going to be, because they're going to have to do a longer retro propulsion, I believe, in Mars that they're going to have to do in the Earth. So that's going to be a different header tank kind of arrangement. But that all being said, is I think they're going to have to look at the design of the pipes themselves. Maybe that will be incorporated in version 3. So maybe their diameter is bigger, maybe their length is shorter, maybe they have some more bends in them, which can compromise some of the fluid dynamics. But I think it's going to be a hardware, and I think there's going to be software too. What are the engines working at, and how they dial that in so that it keeps it within a frequency range that's workable for the harmonics. So, that's sort of the nature of the rocket stuff, is there's not just one solution, because they fix one and there's going to be something else. So they have to figure out what is the optimum of all of those fixes. So good question, though.
Right. Let's see what the next
yes.
topic is here. Okay, here we go. So here's an evolution of Starship from Boca Bingo.
Right. Yeah. So Boca Bingo did a great job here, showing from the very, very early ones, which would probably be the SN 5, 6, those kinds, and then all the way through 8 through 15, which we saw doing those suborbital flip and burns and coming back and landing. Those are pretty cool. And then you can see how things started to change to some degree. But the biggest change really was the V2. And this chart just shows you how much of a change it really was.
Yeah.
And that's when we started seeing the problems.
Well, Trevor says, hi, peeps from England. Why aren't you talking about the biggest problem? Or maybe you have already. To me, the hinges or the heat shield protection around the flap hinges are the problem.
Well, actually, we did talk about that a little bit earlier, but thank you for the question, Trevor. V2 solved it partially with the forward flaps. And the way they did them is they've moved them, instead of 90 degrees, they're at 140 degrees, so that they're further away from the windward side. And by doing that, it does a couple of things. One, it changes the aerodynamics and the pitching moment of the ship. And I've talked about this in a different video, but one of the problems with the earlier version of the ship is that the flap design, even when fully folded, still protruded into the wind stream, and it caused body drag on the nose, and it tended to want to keep pitching the Starship up. So this design reduces that so much that when the flaps are are retracted, they're almost completely out of the windward side. So that's going to reduce that pitching moment, which is an important part of stress of the ship. And the other thing that it did is it moved it out of that plasma stream quite a bit. So the flapped body interfaces have been shrunk significantly, and the seals for the flap to that enclosure are a lot simpler and a lot smaller, and the enclosure and that body interface is a lot smaller too. So that should reduce that heat flux on the at least the forward flaps. So that's what we need to see with these launches, is did it work the way that they thought? And they tested it, they're confident with it, but we need to verify that. As far as the aft flaps are concerned, one of the from what we can know right now is it seems like those did pretty well, but it also had a problem with the forward flaps trying to pitch it all the time. They had to have the other flaps out even more, maybe farther than they wanted, to try to arrest that pitching moment, because you want the other flaps to pitch it back down. So the earlier version of the ship was kept doing this. So it was putting a lot of stress and a lot more load on those lower flaps. By having the less load on the nose, it should reduce the load on the rear too. So we need to validate, did that actually affect the heat shields and the thermal loading that goes on with the ship? So, it was a great question. I hope that answers it. But this is why Ship 35 has to get through the reentry, is they have to be able to test this. They need this information.
Yeah, for real. And so here's another photo. I guess this is the one without your color coding.
Right. And it's just a great shot. It looks like there's only 3 tubes, but one of them is hidden behind the central tube. But yeah, this is the design, at least as it was with 33, 34. And I don't know what they've done with 35 to modify this, at least to get it through the rest of the V2s. And there we go.
And so here's you in Florida. So we have some B-roll that we're going to be showing from your Starship investigation, because obviously they want to launch Starship from Florida as well.
Yes, they do. And it's coming up quicker than I think most people realize. There's a lot of infrastructure that is going on out there. And this is a video I shot out at 39A. You can see the tower that's used for the Falcon 9s right now. In fact, later that night, there was another launch. But here is the Starship tower. You can see that they're doing a lot of work on the chopsticks, which is very similar to the second tower at Starbase. And then underneath that area, it's hard to see because it's under the ground, but they're building the flame trich. And it's also a carbon copy of the one that's going on at Starbase right now. This one, I would say, is maybe 6 months behind what we're seeing at Starbase. And then over at Roberts Road, they're building the orbital launch platform, which is another carbon copy of what we see out at Starbase. And that one's coming along too. This is a shot over by the crawler transitway that brings the SLS, used to bring the space shuttle out. You can see the dirt on the upper right of the screen, and the crawler would go along that way. The road is being widened, and the reason why they're doing this, they're widening it and strengthening it, is this is where Starship will come out, just like at Starbase, but on the SPMTs, and it will go down this route. And if I were to pan the camera to the right, you would see the launch tower in the distance. And so just imagine the iconic shots of Starship leaving here. This is Roberts Road. This is the SpaceX facility. Looking down the road, that's about what you can see. Hangar X, I believe, is that black and white building. And then the tent is where they're building the orbital launch mount right now. Yep. And I was also fortunate, not in this shot, but I saw Falcon 9 coming down the road too, which is pretty cool. And then in the trees, it's hard to tell, but you can see the end of the structure. That's where they do the processing of the Falcon 9s right now. And then just on the right of the screen coming into view is where they're building the Gigabay and the new Star Factory, which will be generally the same as the Star Factory and the new Gigabay under construction at Starbase. And and you can see that kind of structure in the trees. That's a CFA pile driver, and they're putting in the piles for the construction of the Gigabay. So that's coming along really well. And And
Just
so,
pause to say thank you to Ross for the super chat. Great to have a live Ellie and Joe Starship chat as we wait for Flight 9. Hopefully it's coming soon. And congratulations on getting engaged. Thank you so much. It is pretty awesome.
yeah.
It's pretty crazy. So I just wanted to say thank you for the super chat, and thank you, Ross, for always being such a great participant and asking, great questions that help the live stream be even better.
Yeah, thank you very much, Ross. And I know that we jumped through a bunch of different things and we're back at 39A, but I don't know if there's any questions about what we talked about or if you have any thoughts, Ellie, because you were recently out there as well.
I was, and a little behind the scenes of.
Yeah, I know. But I mean, as far as what you saw, it was pretty impressive what they're doing to get ready for Starship. It's not an inconsequential effort. That's huge.
Oh yeah. Oh yeah. I really can't wait to see it out there. I mean, we're just so used to the Boca Chica Starbase setup, and things feel much more polished out there in Florida, obviously, because they've been doing it for so much longer. So I think it'll be, really exciting. And there's definitely a lot of SpaceX activity. I mean, they're not sleeping on this. I know that that tower started to go up kind of quite a while ago, right?
Right. And they've gone through some changes. They used to have an orbital launch mount very similar to the first one at Starbase, and they ripped that sucker down when they realized the one at Starbase was not, shall we say, reusable, survivable in its form. So now they're going to the flame trench.
Right, right. So here's some more video you took.
Yeah, this is just, again, you can see the tower for Falcon 9s and the processing facility on the left, and the proximity of the launch tower for the Starship and 39A. It's very close. It's about as close as the two towers at Boca Chica, or at least Starbase. And this is from the press site looking across the turn basin over to 39A, and again, the tower for the Starship, and then the black tower, which is used for the Falcon 9s, and also where most of the crew that go to the ISS have been launching from.
Yep. Which I saw back in March.
That's very cool. All right. This is sort of switching gears. NASA has its own part of the moon program, and they use the SLS rocket. And there's a newer version of it going to be coming along for, I think it's Artemis 4 and beyond. And it's called the Block 1B for the SLS, and it needs a bigger tower, a mobile launch tower. They put the whole stack on this tower and mobile system, and then they roll it out as one big unit from the BAB. And they're in the process of building that tower, Mobile Launcher 2, and these are some segments that are under construction for that. I saw another segment on the road on the way out while I was there, and then another one was just being added onto that launch tower. It was actually kind of neat there you go. That's what it looks like right now. It's kind of neat to see this coming together after all of the delays, but it's also, I don't know how much your crowd knows, but this is also one of those stories that we saw with the NASA IG that kind of isn't the great part, and that is delays and cost overruns.
So I had a completely different feeling when I looked out at this, and when I was there, I was like, I really don't know what's going to happen with Artemis. And, you're talking about Artemis 4.
Right.
Are we even going to see an Artemis 4? And also, you're talking about cost overruns. This thing is already so much more expensive and behind than they intended it to be. And so I felt kind of weird looking at it, because it's the fate of Artemis is really kind of unclear right now. And so it just, to me, I got kind of a weird, this is being celebrated, and it almost feels like it's charades or something of oh, look at everything that we're doing. But
yeah, it's almost kind of like a death watch. You know it's being built, but you also know that it may be canceled.
That's the thing. And let me see here. Eric Berger put out, I haven't reported on this, but he put out an article yesterday about some leak. Let's see. So NASA just swapped a 10-year-old Artemis 2 engine with one nearly twice its age, and I think it's been leaking. Did you see that?
Yeah, it's a similar tower to this for the block. The original block of the SLS is inside the VAB, and that's where they've been stacking the solid boosters. They just put the central core and the interface onto it, and this is getting ready for Artemis 2, which is currently scheduled to go early next year, which is also it has been delayed a lot too. But so that one is mostly stacked. They're waiting for the Orion capsule for them to, give it its clean bill of health and mount it up there and everything. But on that stack, one of the 4 RS-25s of the SLS was leaking hydraulic fluid, part of I think the thrust vector control. So they elected to remove that engine and replace it with another one, and they'll refurbish that engine for a future time. And these are the same. Some of them are the same engines that were actually flown on space shuttles, and then some of them are new versions that are being built of that same design with some upgrades. And it's a little bit blurry, but this is that shot across the Banana River over to that Mobile Launcher 2 as it's being constructed right next to the VAB. Mm-hmm. And the VAB is about 600 feet tall, so that gives you an idea of the height of that tower. And then if I pan to the left, this gives you an idea of where the Starship tower and pad 39A is located. And we're just seeing several of the other launch sites as we pan by, and then we should start seeing there you go. That's 39A with the launch tower for both the Falcon 9 and the Starship. And that gives you a good idea of the height difference.
Yeah, for sure.
Yeah, but I don't know. Artemis cancellation is sad, but obvious choice. Yeah,
Artemis cancellation is a sad but such an obvious choice they need to make. Artemis 2 and 3 have to happen, though. There's really no other way to beat China by 2030.
Yeah, I think right now is a very interesting time because the person that will weigh in the most about what the direction of NASA, Artemis, and our space program is the next administrator, which has not been selected formally yet.
Well,
we think it's going to be Jared. Yeah, we think it's going to be Jared. But once he is confirmed, assuming that is the case, then I expect him to come out pretty quickly with what is the vision, the priorities of NASA, and we will start getting that idea.
Well, why don't we talk about, because this was just news yesterday, and I made a video about it, but there wasn't a unanimous vote in favor of Jared from that committee. And now that vote moves to the full Senate. However, a lot of people were surprised that it was like 19-9. Did that surprise you?
No, I actually thought it was going to be closer than that because these days everything is political. So it just seems like one party is going to be for and one is going to be against. So I actually took it as a pretty positive sign that it was more of a spread than it really was. 19-9 is better than what is that, 14-15 or something.
Yeah. But do you think that it'll happen?
I do. I think the biggest impediment or slowing him down was most likely Ted Cruz and a comment Elon made about deorbiting the space station early and like in 27.
Didn't agree with that according to his testimony.
No, he did not. But I think that got Ted Cruz upset because the ISS is managed in Houston, and there's a lot of people that have jobs doing that, and it also gives a lot of credibility what's going down at Johnson Space Center. So that's in Ted Cruz's district, or at least area of Texas. So I think when he heard that, he was a little bit dismayed. So I think that delayed things to some degree. But I think Jared has commented that Mars is great. That's what we want to do. But the moon is also going to play a role. And there's some speculation that Artemis 2 and 3 will go as planned. Then after that will be a big question of what they do. And, going back to that Mobile Launcher 2, does that get finished or not or what? And it also kind of dovetails back into what we were talking about with Starship. It's very likely that part of NASA's future is going to be relying more on commercial space like Starship. And if Starship's having teething problems as it's going through its development, that could affect national space policy. So you can kind of see how all this is starting getting coiled together, and the importance of what's going down at Starbase with what we may be hearing from NASA in the near future.
Well, and just a side note, check this out. This is a bill to bring Space Shuttle Discovery home to Houston. And so I don't know, did you know about that?
Yeah, I think this is.
So basically, they're trying to, remove Space Shuttle Discovery from Virginia to its, quote, rightful home near NASA's Johnson Space Center in Houston. What do you think about that?
Well, I think there's the political play that's going on right now. Okay, I understand that. But there's the practical aspect too, is how are you going to actually move it?
Right.
We don't have the 747 to fly anymore. It can't go on roads. And I don't think it was really designed to be sectioned apart and then reassembled. So, maybe you could do it, but the cost would be just so humongously prohibitive. I just don't see it happening, to be honest. That's my take. I may be wrong. But I think the window of time for that to have happened was years ago, not now.
Well, maybe do you think that the argument is valid for it to happen? Like, why is there this push all of a sudden? Like, is this really necessary?
Honestly, I don't. This is going to sound kind of weird, but when I was at Florida going through the Kennedy Space Center Museum, looking at all of our history of space and all the great work that was done, they even have, I think it was Endeavour, the space shuttle there, which was really nice to see. But I couldn't help the feeling that, it's great to look at this history, but this is history. We have such a great golden age of space happening now with so many neat, cool things that are developing. And why don't we, we think about the past. That's great. We learn from it, but let's look at the future and let's embrace that and move forward. And that's what I'm hoping Jared will do for NASA is, we have a legacy, but we also have a future, and let's focus on the future. And I think a lot of this kind of play is backward looking versus forward looking. So, my thought is let's just go for the future. Let's stop playing these little games and enjoy with what we've got and move forward.
Right. Here's some more B-roll you got.
Yeah, this is from the press site, just looking at the VAB and that new launcher system being built. Just inside the open door behind the control room, it's really hard to see, but there's an open door on the ground level, and that's where the Artemis 2 is being assembled, and it's on that platform.
Is that to the right side?
Yes. You can see where the big meatball of NASA is, and you can see the two open doors on the top. And you go to the next bay all the way on the ground, you can just barely see the scaffolding of that launch tower sticking out.
Yeah. Thank you, Rodney, for the super chat. Damn, I didn't see the stream until now. Well, we've been going for over an hour.
Wow.
We thought that, we should talk about what's going on with Starship. I've been not terribly MIA. I have been trying to put out videos, but I was out of the country for 3 weeks. And, of course, Joe has also been out of town, and we haven't seen each other because there hasn't been a launch since March 6th of Starship.
Well, it was a good time to do all the travel because I think things are going to get busy very soon.
Yeah. Well, hopefully I need to make more videos. So I need content.
Yeah. Well, and we don't have to go through every single one, but I think we've already seen this, but that's again, that mobile launcher 2. And I was just at the right place at the right time. I saw that top module being put in. I saw another one rolling on the street right in front of me. And then I saw those other two over on the tents being put together. So it's being stacked.
Yeah. Yeah. I really kind of highly doubt that there'll be a Artemis 4. That just seems, almost silly to say. Maybe I'm wrong. We'll see. Yeah. We'll see. Which, by the way, someone just asked, question, what software, hardware are you using for the multi-camera view and question overlay? So I'm going to drop this link. I am using StreamYard. If you use this to sign up, I guess you can get like a credit or a small discount. But I actually had someone ask me about what streaming software do I use. So I'm using StreamYard. I really like it because I can sort of produce the live stream as we go here. So I'm able to bring up, I'm able to bring up, videos, or I can switch the formats to have us look like this or look like this, or just me, ha ha
Yeah.
ha. And do different banners. So StreamYard has been really cool. Just an aside there. But it's funny. I had someone ask me yesterday, the orthopedic surgeon that I interviewed, if I like it. So yes, I like StreamYard. It's much better than Zoom. And, you can either just pre-record the live stream or the interview, or you can obviously do a live stream. And yeah, so that's just an answer to the many questions.
Yeah. I think it's great that people are asking questions. It's cool. I like answering questions because it makes me think.
Yeah, let's see here. Just trying to see if I missed any questions. Yeah, I feel like we've covered a lot, and I guess we'll see. Starship, we could see it in the month of May. Hard to believe it's already May 1st.
I know, it's hard. Wow.
It's been so crazy. Yeah, Ray has a good point. I'm 65. Hurry up, NASA. It's funny because I'm like not joking when I say I really hope that I get to see humans go to Mars in my lifetime. It may sound like, oh, well, of course it's going to happen, but I think that these things are turning out to be a little bit more complicated and delayed than I think, people may recognize. So
Yeah.
we'll see.
Well, you can see what's recently been going on. Like, Firefly tried to launch yesterday or 2 days ago, and they had another malfunction. It just shows you how difficult it is.
Yeah.
And, but then ULA was able to launch their Delta 5, and that went okay. Got Amazon on the board with a few satellites. So, it's sort of, 2 steps forward, 1 step back kind of thing. But I think we're on the right trajectory. And I'm with you, Ray. I hope that they hurry up as well. 20, 30 years ago would have been great to see where we're at right now. But here we are.
Yeah. It's crazy how there was just I feel like this big lapse in, excitement and optimism for space.
Yeah. I think it's coming back. It was really cool out at Kennedy Space Center to see how many people were out there from all over the world, looking at space and talking about rockets and learning about where we're going. I thought that was fantastic. So hopefully we're getting into that point where people realize that we're in that second golden age of space, and this is just an exciting time.
And Rob says, thoughts on Project Kuiper. The first launch was this week. So yes, they launched those 2 prototype satellites in 2023. And now in 2025, they finally got their first batch of 27, launched, which is crazy how long this has been taking. Some people were asking, well, why is, Amazon's Project Kuiper not launching on Blue Origin? That doesn't make any sense, right? Why wouldn't Jeff Bezos use his own rocket company? And obviously New Glenn was not operational for a very long time. New Shepard is only suborbital. And so what they're doing with Project Kuiper is that they're using, ULA, and then they also apparently they're going to be using a SpaceX Falcon 9 pretty soon here. So they're
I think there's at least 2 launches coming up in the next month or 2.
Right. So they're using multiple companies for, some redundancy, I guess. But I think it is a good question, because if people don't know a lot about it, it is kind of like, why wouldn't he use his own Blue Origin rockets? And so there's a little bit of that explanation.
Yeah. Well, they plan on using Blue Origin, New Glenn, when it's ready. The new ULA Vulcan. They're using Delta 5. They're going to use SpaceX and the Ariane 6. They're probably several years behind where they were hoping to be. Starlink is starting to become really established now, so that'll be interesting to see. And there, I'm sure it'll get waived, or they'll come up with an exclusion or something. But there is still a need per their FCC license to have half their constellation by next year. That's going to be really hard to do.
I was just about to say, I think that's another important thing that I forgot to clarify is that even if they wanted to wait for New Glenn to be operational, they can't per that agreement. And
Mhm.
so, what exactly is the criteria to get half of their
I think they
constellation?
have to have half their constellation up and running by some date in 26. I don't know if it's the end of 26, but somewhere in 26. And if they don't, then I think that they run the risk of losing the frequency spectrum that they have reserved.
Right. And we have the audience filling in the blanks. Thank you, Pete's Guide. The shareholders sued Blue Origin to force them to launch on competitors' rockets to get the satellites in orbit sooner. So I think there was some initial, resistance and, oh, we don't want to use SpaceX. That would
Right.
look so bad. And SpaceX was like, the more the merrier, like it's money and competition is good. And so they're finally getting down with SpaceX.
Right, right. I think the bulk of the question from the shareholders was, due diligence to the shareholders. You have this product that we want to see going, and you're not using all options that are available.
Yeah. So what the heck, man?
Hmm. So here we go. But I mean, SpaceX has launched OneWeb. They've done Viasat. They'll
Yeah.
do Kuiper. They'll do anything.
Yeah. Yeah. Except for probably. And so what exactly is going on? Because I think China is doing their own sort of version, right?
Yes, they have. I forget the name of it, but they are also starting to launch up their constellation system, and you know,
Oh, okay. Here it is. China's primary competitor to SpaceX's Starlink is the 1,000 sails Qianfan constellation, also known as G60 Starlink. What the
hmm.
heck? They're using the same name and likeness. This
Well,
project
they use the likeness for everything else. Might as well use the name too.
This project aims to create a global low Earth orbit satellite internet network. Sound familiar? Potentially rivaling Starlink's reach. China is also developing other LEO satellite constellations, including Guowang and Hanghu 3.
Yeah.
Okay.
Low Earth orbit is going to become pretty saturated over the next decade or two, and
Right.
the big appeal is the latency. So the lower you are, the closer to Earth, the less time it takes for the signal to go up and come back. So everybody wants to try to get them as low as possible, but as high as they can to keep them from re-entering, in a reasonable
Mm.
amount of time. But
Well, and you're right because Starlink already has, I think, over 8,000 operational satellites in orbit, over 5 million customers in more than 100 countries. They want to have up to 42,000 satellites in their mega constellation, but China also wants to have 38,000 satellites. So that's already just between those two a
right.
lot in low Earth orbit.
Yeah, space is big. It's actually, I mean, in aviation, we talk about the big sky theory of not running into things, and low Earth orbit is farther out, so the volume is bigger. But when you start adding that many in, it gets crowded.
And thank you, Josh King, for the super chat. I'm glad that you're enjoying the chat. We're just kind of, talking about all sorts of things. I feel like there's always like so much going on, and sometimes maybe it doesn't necessarily merit an entire video, but it is nice to, I don't know, talk about it.
Right. By the
There's
way, speaking of my trip to Florida, and Kuiper is just north of the VAB is a gigantic new facility for Amazon to build the Kuiper satellites.
Was
And
that one of the videos that you sent?
I think I have a picture of it somewhere. I don't know, but it was quite impressive as far as the scale of that building. So
Yeah,
they are planning on making a lot of satellites.
for sure, for sure. And
I also have shots of the Blue Origin facility too. I went and visited there as well. I know
nice.
you've been there,
Yes.
and there was a couple of interesting developments while I was there. Well, one was a little while ago over in the 2CAT, which is the cleaning and processing facility. They had a test tank RUD inside, and it blew the doors off, and you can still see the doors off. But in addition to that, while I was there, and there were some pictures of it, I tried to get pictures, but my phone wasn't that great. But they have I think it's a New Glenn upper stage tank that crushed itself inside, and you could see it with looked like a bridge crane on the top, and it was all crumpled in, and it was certainly not planned. So if you add all it together, I think they've had 3 upper stages in some way or another be damaged over the last year. So, they're trying to get the next New Glenn to launch. It's been January is when they launched the last one, and what I had heard at the time, I maybe it's true, but they had planned on the booster actually coming back, and they wanted to use it again to launch quickly. And when it did not come back, it's kind of delayed them a little bit. So it may be June or later before we see the next one now. And if they're losing some upper stages, that's not great.
Oh my gosh.
And you've been there, so you know how secretive they are. So it's really hard to get any information out of them.
Yeah, they only let me film in the lobby. Everything else, had to use photographic memory that I do not. It is not applicable to rocket stuff.
Oh, I guess while I was there, they did do an upper stage static fire, though, out at Launch Slick 36. So, they at least had that going.
Yeah. And so let's see here. The militarization of low Earth orbit is about to occur. Weapons everywhere. Golden Shield will be added or built like Starlink, which I haven't mentioned any of that yet. Let me see if I can pull up a quick, description of what that is. Let's see, because that was in the news also recently.
While you're doing that, another thing that's going to be big in low Earth orbit, what I talked about when I was out at Florida, was on-orbit refilling, and a lot of the depots are going to also be in low Earth orbit. So everybody wants to get to low Earth orbit.
Right. And so do you know much about this Golden Dome missile shield?
I know it's what is it, like $20 billion what they've got set aside for it, and they've been getting a bunch of companies. SpaceX is one of them, most likely because of the Starship satellites that they have. But idea, yeah.
So here it is. The 3 companies met with top officials in the Trump administration and the Pentagon in recent weeks to pitch their plan, which would build and launch 400 to more than 1,000 satellites circling the globe to sense missiles and track their movement. A separate fleet of 200 attack satellites armed with missiles or lasers would then bring enemy missiles down, 3 of the sources said. The SpaceX group is not expected to be involved in the weaponization of satellites. Okay, so there we go. That's also in the works.
Yeah, it's gonna, there's always a lot of positive for the future, and then there's stuff like this. And
do you think it's not necessary?
Well, a lot of stuff where you go to kinetic weapons and stuff like that is probably not necessary. It's just a reflection of human nature wanting to control things, and you have multiple parties that want to control whatever, whether it's access or resources or communications, whatever, and then you start having these conflicts. And this is, earlier one of the commenters talked about Artemis 3 and 4. It's the only way to beat China to the moon. Well, the moon is going to become a high ground too, and that's another place, most likely probably for access and resources, that's going to bring potential conflict. And that's why some people want us to move faster and get to the moon, so we can not just plant the flag, but we can actually be there and lay claim to our area. And then they also have the Artemis Accords, which is trying to talk about how the free use of the moon and space is going to happen. But yeah, I think that's the thing, is low Earth orbit, moon, probably even Mars at some point. It's all going to have some sort of militarization aspect to it. And the worst thing is not that I'm hawking a book or anything, but I got a chance to read and then become friends with an author of a book called Mission to Mars 1, Surviving the Kessler Effect. And the part of the book has to do with the Kessler effect, which is debris in orbit, and then it feeds off more, hitting other satellites, whatever, and then making more debris and getting to the point where it cuts off the ability for us to operate, because there's just too many of these high energy projectiles. And when we add all these satellites and we add, weaponization and things that can blow up other satellites, it makes that risk more real.
Yeah.
And I think it's Christopher Lee Jones, and his book is out right now. He actually asked me to read it and give critical analysis to it. And through that process, we became somewhat friends, which is neat.
Oh, are you going to do a book report?
We'll see. I mean, I gave him my scientific opinions of the book, and I think he's taking that, and he's in the process of writing Mars to Mission 2. So hopefully it'll incorporate some of that.
Yeah, I really liked Packing for Mars by Mary Roach. Also, of course, Liftoff and Reentry. Yeah. Highly recommend if you're a SpaceX fan. I think Liftoff is sort of essential reading.
I agree.
And features your friend Anne.
Yeah, my classmate.
Yeah, it's so crazy to think of where they are now, but still have a long way to go.
Yeah, we do. But I think things are looking positive. Despite what we just talked about, I think we're still looking at a positive future, and I'm excited about it.
Yeah, and I know everyone here is excited. So thank you guys so much for joining us. We hope that you enjoyed the live stream. Thanks,
hopefully
Joe.
It was helpful and informative and not too much in the weeds.
Well, I mean, apparently for my audience, they do exactly what you were saying. I'm the only one in the back of the class, sort of.
Well, the most important thing is to understand the challenges that they're working through and why is it so hard. And that's what I was trying to give a little window to. Yeah.
When are you going to work for SpaceX?
I don't know. I saw that they were looking for a fluids engineer to look at harmonics. And
did you do it?
I don't know. I maybe in the past, but I'm kind of not current on that anymore. So everything I do has to kind of refresh myself a little bit.
Are you sure? You sound pretty current to me.
Yeah. Well, most of my experience has been in the operational realm. So if they needed somebody to fly it, understand the systems and fly it, I could do that.
Yeah.
Wow. And I would love to.
All right. Well, thank you everyone for joining us on this Thursday, May 1st. It's May. It's so crazy. I can't believe it. So hopefully we have Flight 9 pretty soon here. Of course, as always, we'll let you know, as much information as we can get. Bimmer Geezer, thank you for another super chat. No, Ellie, I am sitting next to you. So he's also maybe not so savvy with the math stuff.
Wow, okay.
I think those equations, they just look so overwhelming. It's like my eyes just start to glaze over. It's like I want to understand it, but if I'm obviously not, we must have the opposite brains or whatever, right? Which one is the math-centric one?
I think left brain is more artsy and right brain is more, analytical. I don't know.
Okay, so I'm left-brained, I suppose.
Yeah, I can't help it. I'm very analytical. It's just me.
I can tell. So what are you not good at?
Electrical engineering. I just remember in class at the academy, we were learning something about electrical engineering. We had this big bulletin board and equations and stuff all across it. And then at the end, it was like this little cloud. Poof, a miracle happens. And then there's the solution.
Oh my gosh.
Yeah. So electrical stuff that's not my forte.
Why don't you tell people if they're not familiar? I mean, some people might know your channel where you fly drones over Giga Texas, but like why so much about the space side of things?
Well, I guess my in a nutshell, when I was a small kid, I just really got interested in space. I wanted to do that, and I wanted to do it more than just study it. I wanted to be an astronaut itself. So I started going through all of the process to do that. And I got a chance to meet some influential people in my background, one of which was Frank Borman from Apollo 8. Eventually went on to do Eastern Airlines and other stuff. But he kind of helped mentor me and direct me in the path that I needed to go. And I went to the Air Force Academy, got my degree in astronautical engineering, and went up to Air Force Institute of Technology at The Ohio State University. And I got a double master's in aero and astro. I was a pilot and applied to be an astronaut, and that was what I wanted to do. And the other thing I would just add on that is sort of a lesson I learned that I would pass on to anybody that may be interested in doing stuff like that in the future. I think my mistake was when I was being mentored by people like Frank Borman and all that. We were talking about what it took for him to become an astronaut, which would have been 60s, 70s, and what NASA was looking for. And I was using that as my template. So that's why I academy pilot, engineering degrees, wanted to be a test pilot, all those things. And yet the actual requirements were already changing and they were starting to look for something different. So my advice now is figure out what you're really interested in, get really good at that, and then be able to sell yourself of why you bring something to the table that would be needed for space. And in this second golden age of space, as we're looking at commercial, we're expanding NASA, we're looking at having, instead of a few handful of super highly trained people going to space, we have thousands of people with all kinds of skills. I think, following that path, your own path, and being as good as possible is the way to go rather than trying to follow a template, which is what I did.
So, like, I know obviously that you had a lot of experience in the Air Force, but what did you use that double master's like degree? Did you ever do any contract work for space companies or?
Not really. Nothing really formal. I just ended up getting into the Air Force and then started getting, really into the flying thing. And at first it was to try, there was a period of time where the Air Force was, we had too many pilots for airplanes. So it's one of the reasons why I got my degrees at AFIT, Air Force Institute of Technology, because I wanted to have something that was marketable that I could also use to try to become an astronaut. So I was really focused on that. And I was really good at it at that time. But then when circumstances came up and I basically got too old to be able to apply to be an astronaut, which is silly now that we just had, turning 70 on his reentry. But, I just started putting my focus onto the military, and I just started doing a military career from that point in time. And I'll also be honest that my opinion on space was somewhat colored by the fact that I was disappointed that we really weren't making progress. This is why I keep saying if this was 30 years ago, that would have been ideal. But 30 years ago, we were basically low Earth orbit, space shuttle, and anything beyond that was just not going to happen.
Isn't it funny that in your head, 30 years ago feels like 1970?
Yeah, but it's not. It's
At least for me. It's like, I don't know if you do that same thing. It's like, no, 30 years ago, I was.
Here's something to boil your brain. We are closer to 2050 than we are 2020.
Yeah. Wait, what?
Yeah, we're just about closer to 2050 than we are to 2020.
To 2020? 2020 was 5 years ago.
No, I mean 2000. Sorry, 2000.
Oh, okay. I was like,
sorry, 2000. No. So we're closer to 2050 than we are 2000. And 2000 is the big. The world's going to come to an end because the clocks are going to click over and the computers are going to fail.
Wow. Well, I guess I'm getting old.
You are. You're like 32.
33.
33. Just oh my God.
33. Yeah, just turned 33. So it's all going downhill. No, I'm kidding. I actually feel really good. It's amazing how much better I feel, now that I've had over 2 years since breaking my femur and everything. I feel so good. And, obviously work very hard to feel good. It's not just like magic, but I'm like noticing that I really feel full and able-bodied again.
Isn't that amazing? Because when that happened, remember we had that discussion that had you had that break maybe 30 years earlier, you may have been maimed for life.
Yeah, for real.
Crazy.
I mean, yeah, I'm very lucky. And, as much as I don't really want like a titanium rod for the rest of my life, like, I don't really think I have a choice.
Hey, but you are a human sonic boom finder.
I don't want to be. I didn't sign up for this and I don't like it. Oh my gosh, someone just said Ellie is ancient. 33 is not that old, okay? Like, I don't know when you start to actually feel old, but I feel like old is really also like a mindset. And, if you are like really physically active and take care of yourself, I think you can stay sharp for a long time.
I agree. And keep trying new things and just don't get stagnant.
Yeah. I don't feel 33. I don't know if you don't feel your age, but I really don't feel 33.
I don't. I honestly, In a lot of ways, I feel like I felt 30 years ago. That's just
Yeah.
weird.
Yeah, it is weird. Time is a weird thing.
Yeah,
Some people would say it's an illusion.
it could be either that or a fundamental part of space-time.
Yeah. Do you think that there's multiple parallel universes?
Hmm.
Do you think there's a Joe that's an astronaut and there's a Joe that is terrible at math?
Could be. I don't know. That's sort of now we're getting into the deep thoughts and metaphysics and everything. I don't know. Maybe. I mean, it's a big universe. There's a lot could happen.
Well, Ditto just gave the best comment of the entire live stream. If I didn't know, I would say Ellie looks 22. Thank
Ah,
you. That is very sweet. I will say it's been interesting. When I was in TV news, I used to wear makeup every single day, and it was such a chore to like put on a full face of makeup and curl my hair and, put it all on and then have to wipe it all off every night. It was just a pain. And since I got out of news, I stopped essentially almost always wearing foundation. I maybe wear it like 2 or 3 times a year now. And I like it so much more to not have to have all this stuff on my face that gets on your clothes and it like melts in the heat. And like, I actually think it makes you look younger. I don't know why women use this sort of cake face when I think it only accentuates those fine lines. And so anyway,
well,
pro
I'm
tip,
laughing because yeah, go ahead.
pro tip,
Well,
less is more.
yes, I was just while you're talking about, I just had a memory Ingram, whatever, just pop in my head. Back when I was a teenager, I worked at Safeway as a kind of a bagger. So I would bag the groceries. Back in the day, we used to do that. Anyway, this is one time I remember distinctly. There was this lady, an older lady, that was there getting her groceries, and I was bagging it. And as I was looking at her, she had so much makeup on. Every time she smiled, you could see the cracks going.
Oh my
And I just thought, oh no, that's terrible.
We call those marionette lines.
Oh, is that what it is?
Yep, marionette lines.
It was like she had like 5 layers more than she needed.
Gosh. That's the thing is like there's been this sort of discussion recently of how these, 22 year olds look a lot older. And it's because they're starting all of this stuff that I think is completely unnecessary. Lip filler and Botox and cake face and maybe boob job and like all sorts of stuff. And it's making them look prematurely aged. And it's just a very interesting, I think, kind of quite sad thing that's happening. But, that's, but I will say I have mostly stopped wearing fake eyelashes. So that's also been very nice. As I told you in the hospital, I didn't want to wear them ever again.
Right.
I did not adhere to that, but lately I don't know.
Interesting time at the hospital. The things that you swore off of. Oh, I'm never going to do this. I'm never going to do that.
Yeah. Never going to rock climb. Not true. But I love climbing. It's so, so fun.
You got to do what you like.
Yeah. All right. Well, that about wraps it up. Thank you guys so much for watching and hanging out with us on this Thursday. Hopefully we'll be back soon. And yeah, it's exciting times. We got a little bit of a break in the action, but I'm sure that Starship will be launching hopefully sometime soon. And I really hope they don't lose the ship again.
Yes, they need to do a full duration.
Yep. All right. Well, with that, I will end the stream. Thank you, everyone. And